Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about probability. Now the question I've chosen to go through here is from 2015, paper 2, and it's question 1. In this question we're told that 2 dice are thrown. So clearly the numbers on the dice are from 1 to 6. We're told that when the 2 dice are thrown, the numbers are added together. And in this experiment, in order to win, the numbers when you throw the 2 dice have to add up to at least 9. So you'll notice here that I've marked in W for all the boxes that indicate that it's adding to at least 9. And all the other values are losses. So for part A of the question, your table should look like this. Now in the second part of this question, in B part 1, we're asked to find the probability that someone will win. So what is the probability that when you throw these 2 dice, the number is going to add up to at least 9? Well, in this case, you should recognize that there's 6 multiplied by 6 columns, which means there's 36 possibilities. And if you add up all your W's, there's 10 scenarios where you win. Which means the probability that you win in this case is 10 over 36. But always make sure that you simplify your fraction into its simplest form. So 10 over 36 is the same as 5 over 18. So for B part 1, my final answer is just 5 over 18. Now in part 2, I'm asked to find the probability to 4 decimal places that each of 3 successive throws will result in a loss. So in other words, I throw the 2 dice and I get a number less than 9, then I throw it again, less than 9 again, then I throw it again and I get less than 9 again. So what's the probability I'll lose 3 times in a row? First thing we need to do here is work out what is the probability of a loss. So I've already worked out that the probability of a win is 10 over 36. So clearly if 10 of the scenarios are losses, then 26 of the scenarios out of 36 are 26 out of 36 are losses if 10 out of 36 are wins. Now 26 over 36 is the same as 13 over 18. So for B part 2, I've been asked to work out what is the probability that I'll lose 3 times in a row. Or in other words, the probability I lose the first one is 13 over 18, and I'm going to multiply that by the probability I lose the second one, which is still 13 over 18. Multiply that by the probability that I'll lose the next one, which is 13 over 18. So I just multiply, I want to lose and then lose again and then lose again. And to 4 decimal places, the probability that this will happen, it's 0.3767. So my answer to B part 1, the probability of a win is 5 over 18. And my answer to B part 2, the probability of 3 successive losses is 0.3767. Okay, so for part C of this question, we're told that the experiment is repeated again and again until 3 wins occur. And we need to find the probability that the 3rd win occurs on the 10th throw of the dice. Okay, so the information I already know is that the probability I win is 5 over 18, and the probability I lose is 13 over 18. Now, I want to find the probability that the 3rd win occurs on the 10th throw, which means I know that I need to win the 10th one. But it's not actually the 10th one I'm concerned with. What I'm concerned with is what needs to happen in the first 9 throws. So in the first 9 throws, I obviously need to win twice and lose 7 times, so that in the 10th throw I can win for the 3rd time. So what we're actually concerned with in this question is what happens in the first 9 throws. In the first 9 throws I need to win twice and lose 7 times. And you need to recognize that it doesn't matter what order I win these in. So this is a combination. A combination is when the order doesn't matter. So I don't care if I win the first one and the 7th one, or I win the 5th one and the 6th one. I don't care in what order I win them in. I just want to win 2 out of 9. So you should start to think in your head that this is a Bernoulli trial. First thing you have to realize is that the first 9 throws is a combination. Now you'll notice I've written out the 4 conditions here for a Bernoulli trial. If it's a Bernoulli trial, that means there can only be 2 outcomes. Well, in this case, I can either win or lose. There's no draw, so I only have 2 possible outcomes. Another condition of a Bernoulli trial is that they're independent events. Or in other words, the probability of winning will be the same with every throw. So if I win the second one, that doesn't change the odds of winning the 3rd one. I will always have a 5 out of 18 chance of winning this game. So there are independent events. The probability of a loss and the probability of win will always be the same. Now, to be honest, 2 and 3 are pretty much a different way of saying the same thing. But in the leave insert, they always distinguish them. So in the marking schemes, you can use these as two different reasons. So the probability of a loss and the probability of a win are always the same, which essentially is the same thing as independent events. My fourth condition of a Bernoulli trial is that there's a finite number of trials. Well, in this case, I am only concerned with 9 trials. I'm going to do a Bernoulli trial for the first 9 trials. So there is a limited number of trials. So once I've satisfied all these conditions, I know that it's acceptable to use a Bernoulli trial. So my formula for a Bernoulli trial is here. So it's in my log tables. To be honest, when I'm teaching this to my students, I rarely actually use that. I think you should be able to figure it out yourself. Okay, so the NC or N choose or, that indicates it's a combination, where the order doesn't matter. So I want to do 9 trials. So that's my N is 9. I want to carry out 9 trials, and I want to win 2 of those trials. So it's 9 choose 2. So I want to, out of 9 trials, I want to win 2 of them in any order. So I don't care when I actually win them, just 2 out of the 9. Instead of calling this W, I'm going to call my probability of success is P. So P is equal to 5 over 18, and my probability of failure is Q. So Q is 13 over 18. So I would sub in, right, it's P, the probability of success is 5 over 18. And I just ask myself, out of the 9 trials, how many times do I want to win? Well, obviously, out of the 9 trials, I want to win twice. So it's the probability of success to the power of 2. And then I need to sub in the probability of failure. So out of my 9 trials, how many times do I want to lose? So in this case, I want to lose 7 times. So 9 choose 2 accommodates for the fact that I don't care what order it happens in. So I win the second one and the 6th one, or the 3rd one and the 5th one, or any combination whatsoever. Then I want to win twice and I want to lose 7 times. So that's my Bernoulli trial. This allows me to work out the probability that I win 2 out of the first 9 trials. But I'm actually concerned with the probability that the 10th throw is the 3rd win, which means I want this to happen, but then I also want to win the next one. So I want to win 2 out of the first 9, and then I want to win the 10th one. So then I'm going to multiply that by the probability that I win the next one. So this is just for my first 9 trials, and this is for my 10th one. And if we plug this into our calculator, we were asked to leave our answer to 4 decimal places. So in this case, my final answer is 0.0791. So again, I hope this video made sense. If there's anything you're unclear on, then just let me know in class during the week or send me an email and I'll try and explain it slightly differently.